Hello students, after completion of A, B, C, D type of question answer and some organic conversions, let us discuss some analytical questions and their answers. So analytical question, here also you have to remember what are the different preparation and properties of these compounds. Next, you have to first in this question, first you have to read this question 1 to 2 times very calm and quietly. Next, what is the clue here? Find out what is the clue here so that from this clue you can totally solve this type of problem. So, and here look here, an organic compound A on treatment with acetic acid in presence of sulfuric acid produces an ester. So, as acid in presence of sulfuric acid it gives ester, then this organic compound may be alcohol. First keep in mind. Then A on mild oxidation gives C. As this is an alcohol, then mild oxidation it gives C, means that is an aldehyde. Then C with 50% potassium hydroxide followed by acidification with dilute HCl generates A and D. So any aldehyde when treated with dilute alkali, then any aldehyde which contains generally alpha hydrogen atom, when treated with dilute alkali, it gives one product, that is alcohol. But here it is given two product A and D. As it given two product A and D, that means this aldehyde is formaldehyde. Because it undergoes self oxidation and self reduction. So in self reduction it again gives alcohol, and oxidation it gives acid, sodium potassium salt of acid, which an acidification gives the acid, and D with PCl5 followed by reaction with ammonia gives E. Again D reacts with PCl5 followed by reaction with ammonia gives E. It may be an amide, and E on dehydration produces hydrocyanic acid. As it is given hydrocyanic acid. This is the clue. Identify the compound A, B, C, D, E. Another thing, I have told you that, so when C reacts with 50% potassium hydroxide followed by acidification with dilute HCl generates A and D. So this is an aldehyde without alpha hydrogen atom. So that means it may be formaldehyde or it may be benzaldehyde. So if that is formaldehyde, then hydrocyanic acid may be produced as the end product. But if it is the benzaldehyde, then it may gives you instead of this benzonitrile or phenyl cyanide. So as hydrocyanic acid HCN is given, and what is the product? So hydrocyanic acid. So what is then E? So from that, as it is hydrocyanic acid and dehydration produces, that means E must be an amide. And what is the amide? So from here just add some water so that E is HCONH2. From that you can HCONH2. As E is HCONH2. By studying this, by reading this question, by analyzing this, first find out what is the clue. So this is the clue. This is hydrocyanic acid given. Then this is produced by dehydration. Just add water here. So you know when amide undergo dehydration, it forms cyanide. As this is hydrocyanic acid, so this is your HCONH2, hydrocyanic acid. Next, this is your E. Okay. So D with PCl5 followed by reaction with ammonia. So D is an acid. It reacts with PCl5 to form acid chloride, and acid chloride reacts with ammonia to form amide. So D, what is? D must be formic acid. This is formic acid. So this is your D. D is your formic acid. As D is your formic acid, then A is what? Then the alcohol which contain one carbon atom, the acid which contain one carbon atom. So this may be, so A may be methyl alcohol. So A is methyl alcohol. And an organic compound on treatment with acetic acid in presence of sulfuric acid produces an ester. So as it is A is here also produced methyl alcohol, and this is E, this is D, this is A. So produces an ester B. So B is and what is C? So C which on oxidation gives this and this. So any C, that is an aldehyde, which on treatment with KOH gives formic acid and methyl alcohol. So as it gives formic acid and methyl alcohol, which is also produced by the mild oxidation of this compound, mild oxidation of this compound. So C must be formaldehyde. So first you analyze this question and keep in mind what is the arguments for this, what are the arguments for this. So why this type of compound is produced, then you write down what is the overall reaction. So first overall reaction, this one is C, this one is C, this one is B. So C is formaldehyde. Okay, then write down what is the overall reaction. Look here, organic compound A, treatment with acetic acid. So A, here we find alcohol, reacts with acetic acid in presence of concentrated sulfuric acid, gives so here H of this and OH of this, it gives CH3 COO CH3. Right side alcohol part, left side acid part. Remember, so this is your ester plus water. So this is the main product. Then A on mild oxidation gives C. So this is A on mild oxidation gives formaldehyde, C with 50% of potassium hydroxide. So formaldehyde treated with 50% potassium hydroxide. So it gives alcohol plus HCOO and K, potassium formate. This potassium formate on reaction with HCl forms formic acid. So this is one. Next, so this is your A, that is your organic compound A, and reacts with this to form compound B, and this is A treated with this to form C. So this compound is C on treatment with KOH form again A and D. So this one is A and this one is D. Then D again reacts with PCl5. D reacts with PCl5. D reacts with PCl5, forms formal chloride, which reacts with ammonia to form formamide. And formamide, So this is E, formamide. E on dehydration produces. So when it is heated with phosphorus pentoxide, dehydration takes place, minus H2O, it forms hydrogen cyanic acid. Okay, so A is your methyl alcohol, B is methyl ethanoate or methyl acetate, then C is formaldehyde, then so you know A this, and D is formic acid, and E is formamide. Okay. Next come to another question. Actually this type of question carries 3 to 5 marks. Some questions carries 3 marks, some questions carries 5 marks. Look here. An organic compound A on treatment with ethyl alcohol gives carboxylic acid V and the compound C. So organic compound reacts with ethyl alcohol. You know, that is, if that is an acid, when it reacts with alcohol, it forms ester. And if it is an ester reacts with alcohol, it forms again an ester and alcohol. So that is trans-esterification. And another compound, so it gives different compound. It gives an carboxylic acid and compound C. That means from that I can gauge that the organic compound may be an acid anhydride. First I have keep it in mind. Next, hydrolysis of C under acidified condition gives B and D. As hydrolysis of C gives B and D, then C is the organic compound, then I can think C may be an ester. So C may be an ester, A may be an acid anhydride. I have that thing in mind. Next, oxidation of D with potassium permanganate also gives B. So oxidation of D, so first gives B and D, and D again on oxidation it gives B. That means B, the carboxylic acid. On B on heating with calcium hydroxide gives E, having formula C3H6O. E does not give tolerance and does not reduce Fehling solution, but forms 2,4-DNPH, 2,4-dinitrophenyl hydrogen. D. Identify A, B, C, D, E. So from all this, when I read this question 2 to 3 times, I find some clue here. That is, the compound has formula C3H6O. As the compound has formula C3H6O, it may, that is your CnH2nO form. It may be an aldehyde, it may be ketone, it may be an aldehyde or maybe ketone or maybe hydroxy alcohol or maybe enol. It may be aldehyde, ketone or it may be enol. So, but what given? E does not give tolerance then rest. That means it is not an aldehyde, does not reduce Fehling solution, not an aldehyde, but forms 2,4-DNPH. That means it is one carbonyl compound. So it is an carbonyl compound. It does not reduce Fehling solution and tolerance reagent. That means the compound must be a ketone. And as the formula is C3H6O, having this formula, the ketone, what is the ketone? The ketone is acetone. So here I found the clue, that is the ketone is acetone. And the ketone is acetone, which is obtained by heating B with calcium hydroxide. That means B must be acetic acid. So B must be acetic acid. So this is your ketone. B on heating with calcium hydroxide gives E, having formula. So this one is E and this one is B. B on heating with calcium hydroxide forms this. Next, again oxidation of D with KMnO4 gives B. So B is an acid and D is an alcohol. Hydrolysis of C under acidified condition gives B and D. As D on oxidation again gives carboxylic acid B. That means D must be an alcohol and B is the acid, that is your acetic acid. So alcohol having 2 number of carbon atom, that is ethyl alcohol. So D is ethyl alcohol. As D is ethyl alcohol. Next, hydrolysis of C under acidified condition gives B and D. As B is acid and D is alcohol, which is produced by hydrolysis of C, that means C must be an ester. So the ester having 4 number of carbon atom, that is ethyl acetate. And see how the C is obtained. C is obtained from the compound A on treatment with ethyl alcohol gives B and D. So you know what is B, what is D, and what is C, then what is A. So as this is ethyl acetate and another is carboxylic acid. Ethyl acetate is C and B is carboxylic acid. From that it is conclude from that this I may conclude that I reach in the point that A may be an acid anhydride and A have the formula this is acetic anhydride CH3COO CH3CO acidic anhydride acetic anhydride. So this acid anhydride, so these are the points. Now wait. And what is the overall reaction? Look here. This acid when treated with ethyl alcohol, when is treated with ethyl alcohol, so bond breaking takes place suppose here. So it forms A H and another H and here O C2 H5. So in this we get acid plus this is your B and C. Okay, acid anhydride when treated with ethyl alcohol, bond breaking takes place, H here and OC2H5 here. In this way it forms acetic acid and ethyl acetate. Again what happens? This when undergo hydrolysis H2O in presence of acid. It undergo hydrolysis here OH and H. So this gives again acid B and so B and D. Again it gives B and D. B is ethyl alcohol. Then ethyl alcohol D with potassium permanganate gives B. When it undergo oxidation with potassium permanganate, it gives again B. B on heating with, when this is heated with calcium hydroxide, it forms calcium acetate. Can you see this? CH3COO whole twice Ca. When it is B, when treated with this, it forms calcium acetate. And calcium acetate, when heated, it forms calcium acetate. When heated, undergo dry distillation, it forms acetone. So, this is the overall reaction. So, what is A? A is acid anhydride, B is acetic acid, C is ethyl acetate, D is ethyl alcohol, and E is acetone. Okay? Next come to next question. An acid A reacts with PCl5 to form compound B. You know, when acid reacts with PCl5, it forms acid chloride. A also reacts with sodium hydroxide to form compound C. So when acid reacts with sodium hydroxide, it forms sodium salt of acid. So acid chloride and sodium salt, when this reacts, it forms anhydride. As the anhydride is acetic anhydride, this is the clue point here, is acetic anhydride, then what are A, B, C? So from this we can find out what is the compound. So this is acetic anhydride. Acetic anhydride means this is acetic anhydride. So as the acetic anhydride contains 4 number of carbon atom, this is a symmetrical anhydride. So this acid contain, from that we can contain, the acid contain 2 number of carbon atom. So acid chloride and sodium salt both reacts to form anhydride. That means the acid chloride is containing 2 number of carbon atom, CH3COCl, this is B, and sodium salt of the acid is sodium acetate. As this is 2 number of carbon atom, this gives this acetic anhydride, and this is your C. And what is the acid? As this 2 number of carbon atom, the acid is acetic acid. This is A. So what is the overall reaction? Look here. Acetic acid reacts with PCl5 to form CH3COCl plus HCl plus POCl3. These are the side product, but we have to write only the main product. Again, acetic acid reacts with sodium hydroxide to form sodium acetate. And again, when sodium acetate reacts with acid chloride, it forms acid anhydride. Okay, so A is acetic acid, B is acid chloride, C is sodium acetate. When these two react, it forms acid anhydride. Okay, next come to next question. An acid A reacts with ammonia. You know, any acid reacts with ammonia to form this ammonium salt and forms compound V. So this is the ammonium salt. B on heating gives a compound C. So when B on heating means removal of water takes place, it forms an amide. C on treatment with bromine and NaOH gives ethylamine. So this reaction is known as Hofmann-Bromamide reaction. When an amide reacts with bromine and aqueous alkali like sodium hydroxide or potassium hydroxide, it forms an amine. And this amine has one carbon atom less from that of the parent amide. As the amine is given ethylamine, this is the key point or clue point. Write the name of ABC. So how we solve this? Look here. So given ethylamine, this is ethylamine, and this is how this is obtained. This is obtained by reaction of bromine and sodium hydroxide by Hofmann degradation reaction. In this, the CO group, CONH2 group is changed to NH2 group. As the CONH2 group is removed to changed to NH2 group, then what is the parent amide? The parent amide is C2H5CONH2. So the parent amide is propanamide. This is Br2K NaOH given. Br2 and NaOH. It gives this. And how this is formed? This is formed by heating one ammonium salt. Then what is the ammonium salt? This ammonium salt is minus H2O. So this ammonium salt is ammonium propanoate. And how this is formed? This is formed by reaction with ammonia. An acid when reacts with ammonia. So an acid reacts with ammonia. So what is that acid? That acid is propanoic acid. So this is propanoic acid. This is A. When it reacts with ammonia, it forms ammonium propanoate. This is B. B when heated, loss of water takes place. It forms amide, that is C. And C when treated with bromine and KOH, it forms ethylamine. So given, write the name of ABC. What is A? A is propanoic acid. What is B? B is ammonium propanoate. What is C? C is propanamide. Okay. So in this way you can solve this type of question. Next, come to another question. A colorless, pungent smelling liquid having chemical equivalent 46. Pungent smelling. You know the lower carboxylic acid have pungent smell. Strongly acidic to litmus. It is strongly acidic to litmus. That means and having pungent smell, acidic. That means it is one acid. First thing, keep in mind, this is one acid. So acid having chemical equivalent. As these are monocarboxylic acids, they have chemical equivalent 46. That means it may have the molecular mass is also 46 gram. This is readily oxidized by potassium permanganate. So this is acid and chemical equivalent 46 and oxidized by potassium permanganate. From that we can conclude the acid may be formic acid. Another thing, oxalic acid also oxidized by potassium permanganate and formic acid also oxidized by potassium permanganate. But oxalic, but formic acid reduces mercury chloride to mercurous chloride. As it reduces mercury chloride, it oxidized by potassium permanganate and again it reduces mercury chloride. That means that acid is formic acid. And again, what is given? So you have to write this point as like this. As the chemical equivalent is 46 and this is strongly acidic to litmus. This is one carboxylic acid. This is red as it oxidized by potassium permanganate and reduces mercury chloride. So the acid is formic acid because other carboxylic acid do not reduce mercury chloride. Heating the original substance with excess of sulfuric acid produces water and carbon monoxide. Other carboxylic acid when heated with sulfuric acid, monocarboxylic acid when heated with sulfuric acid, they form acid anhydride. But formic acid is the one monocarboxylic acid which when heated with sulfuric acid, it forms water and carbon monoxide. So from all these points, we know that the acid is formic acid. Okay. So what are the different reactions? Look here. Potassium permanganate reacts with sulfuric acid to form potassium sulfate, manganese sulfate, water and oxygen. Then formic acid reacts with this oxygen to form carbon dioxide and water. So the resultant is there are 5 oxygen multiplied by 5 plus give rise to potassium sulfate, manganese sulfate plus, so it oxidized by potassium permanganate. Next, it reduces mercury chloride. Mercury chloride, formic acid, HgCl2 give rise to mercurous chloride plus carbon dioxide. And another, when formic acid heated with concentrated sulfuric acid, it forms carbon monoxide and water. Removal of water takes place, carbon monoxide and water. Okay, so what is the structural formula? This is the structural formula of formic acid. So the acid is formic acid and this is the structural formula. Okay.